All right, we're going to be looking at the effects of changing certain parameters on reaction rate, and so we can follow along with what is on your handout. So first we're going to start off with 1 molar hydrochloric acid and 6 molar hydrochloric acid, both of which we're going to stick a piece of zinc metal into. We know that this will be a single replacement reaction, which we've seen back in the reaction unit. So right here we've got the 1 molar HCl, here's the 6 molar, and so we'll drop in the metal pieces and see what happens. So if it's a reaction between zinc and hydrochloric acid, oh, I forgot to put the 6 molar hydrochloric acid in there, so that one's probably not going to react very well without that. There we go. So anyway, zinc plus HCl, single replacement reaction. So one of the products is going to be hydrogen gas. So the fact that we see bubbles tells us that there is hydrogen being produced. And so notice that although both of them, let's see if we can get the shot in the camera here. So the one on your left there is the 1 molar HCl. And notice there's just very little bubbles on the surface, but it's bubbling, but more slowly. So it is reacting, it's just taking a little bit longer, versus the one on the right-hand side, which you can see is bubbling pretty vigorously, and so that means that it's reacting a lot faster. Okay, so you can record your observations for those. Secondly, we've got 1 molar HCl that is at 20 degrees Celsius, and then we've got 1 molar HCl that's at 60 degrees Celsius. And we're going to put our zinc metal into there. So here's the 60 degrees Celsius. So you notice it's a little bit steamy because it's hot. And again, give it a minute. And so same reaction. So we're seeing bubbles as our sign of chemical change here. And notice the one on your right is, well, the tube looks a lot cloudier, and that's because there's a lot more vigorous bubbles coming off. So I'm going to pull it up closer versus this one here. So bubbles on both, but the 60-degree one's going a lot faster, producing bubbles a lot quicker. Next we've got the 1 molar calcium chloride, the 1 molar hydrochloric acid with the calcium carbonate chunk, so it's a marble chip, versus the crushed marble chip. And so let's see what happens there. Put that guy in there. And we get a scoop of the calcium carbonate. So it's the same compound, just different surface area. So I can get this in without spilling it everywhere. Okay, so notice the bubbling here. And there's the chunk. So you've got some bubbles at the surface of the chunk. And that's carbon dioxide being broken down from the carbonate ion and the calcium carbonate. And we've got bubbles here, but notice how many bubbles. It kind of looks kind of cloudy from all the bubbles in that one. And the one with the powdered calcium carbonate. And lastly, we've got the effect of a catalyst. So this is hydrogen peroxide. It looks kind of like water, but it's H2O2. It is mixed in with water, but there's hydrogen peroxide there. And so hydrogen peroxide actually will decompose into water and oxygen. So it goes from H2O2 to H2O and then O2. And so this actually happens very slowly over time, normally. Not enough that you can see any active bubbles in there, so that's, so nothing's happening. But eventually, over time, you'll notice the hydrogen peroxide decomposes and doesn't have the same effectiveness that it used to. If you think about it, hydrogen peroxide is usually in these like dark bottles, and that is to help protect it from sunlight, which will also help speed up the decomposition process. So what I'm going to do is put some of the catalyst in here. I'm going to use, instead of MnO2, I'm going to use some yeast, just because it's a little bit easier to clean up. And we'll see what happens. So again, this process of decomposition will happen. It normally happens very slowly, but now if I put in yeast, a catalyst, if I open the container, that would be helpful. There it is. So notice we go from having no bubbles And of course the yeast is now kind of floating on the top there, but now we've got some bubbles. And so again, that's that oxygen gas being produced. There's also water being left behind, but obviously the water looks exactly the same as what we're starting with. Those bubbles in the top show me that there's a gas being formed, and that is that oxygen. So we've sped up that decomposition by adding yeast, our catalyst. And that is it for your observations over the worksheet.